Tonight, we're exploring the mysterious world of blue whales, the largest animals to ever live on Earth. From ancient ancestors to hidden ocean songs and deep sea survival, this is a relaxing journey into the secrets of these gentle giants. Before we begin, leave a comment below telling me what city you're watching from tonight. And if you enjoy documentaries like this, don't forget to subscribe and let me know what topic I should explore next. Sleep well tonight. Far out in the cold Pacific, there are nights when the ocean feels less like water and more like outer space. No cities, no lights, no sense of scale, just black waves moving beneath a sky filled with distant stars. And somewhere under that darkness, something larger than any dinosaur is alive right now, moving silently through the deep. For most of human history, people had no idea such a creature even existed. Ancient sailors crossed entire oceans without truly understanding what was beneath them. They told stories about sea monsters, moving islands, creatures large enough to swallow ships whole. Most of those legends were exaggerations, born from fear and fog. But hidden inside some of those stories was a strange truth. There really were giants in the sea, creatures so massive that the human brain struggles to process their size correctly, even when looking directly at them. Because a blue whale does not look real at first. It looks misplaced, like something from another era accidentally surviving into the modern world. A fully grown blue whale can reach lengths close to 100 feet. That is longer than many city buses parked end to end. Its tongue alone can weigh as much as an elephant. Some individuals may weigh over 150 tons, though exact measurements vary because weighing a living whale in open ocean is almost impossible. Even scientists often rely on estimates built from stranded animals, scanning technology, and older whaling records. Still, one conclusion appears again and again. No animal humans have ever discovered seems to surpass the blue whale in total mass. Not Tyrannosaurus rex, not Spinosaurus, not even the enormous Argentinosaurus, one of the biggest dinosaurs ever reconstructed from fossils. That detail changes the emotional feeling of the ocean almost immediately. Because suddenly, the modern world no longer feels like the age of small creatures living after the giants disappeared. The giant is still here. And unlike dinosaurs, blue whales are not trapped in stone. They breathe. They migrate. They sing beneath living oceans tonight. The strangest part is how easily they vanish. A creature larger than some airplanes can disappear beneath the sea within seconds, leaving behind nothing but a widening circle of dark water. That almost feels impossible, but oceans distort scale in ways land never does. Mountains beneath the sea remain invisible. Entire canyons vanish into darkness. So the blue whale evolved inside an environment where being gigantic does not necessarily mean being visible. In fact, water may be the only reason such an animal could exist at all. If a blue whale suddenly appeared on land, gravity would become catastrophic. its own body weight would begin crushing organs and restricting movement almost immediately. On land, giant size becomes dangerous very quickly because skeletons must carry everything alone. Water changes the equation. Buoyancy supports much of the whale's mass, turning the ocean into something like an invisible suspension system for giants. And blue whales push that advantage to an extreme. Their bodies are not built like giant predators from movies. They are streamlined, almost elegant. Long, smooth curves designed not for fighting, but for efficiency. Scientists studying whale movement discovered something surprising. Despite their size, blue whales can travel enormous distances while using energy remarkably well. Their shape reduces drag. Their tails produce immense propulsion with slow, controlled movement. They do not waste motion. That efficiency matters because gigantic life comes with gigantic costs. A blue whale consumes astonishing amounts of energy, yet it survives almost entirely by eating tiny, shrimp-like creatures called krill. This sounds absurd the first time you hear it. The largest animal in Earth's history surviving on prey smaller than your finger. But in certain parts of the ocean, krill gather in numbers so vast that they become living clouds beneath the water. A blue whale does not hunt individual prey. It hunts density itself. When feeding, the whale lunges forward and opens its mouth so wide that it takes in enormous volumes of seawater filled with krill. The expandable folds beneath its throat stretch dramatically, transforming the animal into something almost mechanical looking for a few seconds. Then, the whale forces water back out through long baleen plates that act like giant filters, trapping the krill inside. One feeding lunge can involve more weight than many elephants combined. And yet, despite all this power, blue whales are strangely fragile in some ways. Scientists believe they may already be approaching biological limits. Their hearts, for example, operate under extraordinary strain. Researchers attaching temporary sensors to whales discovered that during deep dives, a blue whale's heartbeat can slow to only a few beats per minute. Near the surface, the rate increases again as oxygen floods back through the body. The scale of that circulatory system is difficult to imagine. Some arteries are so large that exaggerated stories began spreading for decades, claiming humans could crawl through them. The reality is more complicated, but the fact those myths sounded believable says a lot about the animal itself. Even the true measurements feel unreal enough. And perhaps even more incredible is how blue whales store oxygen. Humans rely heavily on breathing constantly because our oxygen reserves are limited. Blue whales evolved differently. Their blood contains extremely high concentrations of hemoglobin, while their muscles hold massive amounts of myoglobin, proteins that store oxygen directly in tissue. In effect, their entire body became a giant oxygen reservoir. That adaptation allows deep, prolonged dives that would quickly suffocate most mammals. But large size creates problems too. For all their power, blue whales cannot accelerate rapidly like smaller predators. Their enormous mass creates inertia that takes time to overcome. Turning quickly costs energy. Sudden movement becomes inefficient. Scientists studying whale biomechanics suggest that, beyond a certain point, increasing body size may actually create diminishing returns. Bigger animals gain advantages in heat retention and migration efficiency, but they also face rising energy demands and movement limitations, which raises a fascinating possibility. Maybe the blue whale exists very close to the upper boundary of what biology can support on Earth. Too small, and long migrations through cold oceans become inefficient. Too large, and the body itself becomes increasingly difficult to power. Some researchers suspect blue whales reached this size partly because Earth's oceans created unusually favorable conditions after ancient climate shifts. Nutrient-rich waters fueled massive krill populations. Cold environments rewarded large insulated bodies. Vast migration routes encouraged energy-efficient gigantism. In other words, the blue whale may not simply be an accident of evolution. It may be the result of an entire planet aligning in exactly the right way. And that thought becomes even stranger when you remember that whales were never supposed to be here in the first place. Their ancestors walked on land. Millions of years ago, distant whale ancestors resembled four-legged mammals living near rivers and coastlines. Over immense stretches of time, evolution transformed those creatures completely. Legs became flippers. Nostrils migrated upward into blowholes. Bodies stretched longer and smoother. Tails became engines, powerful enough to cross oceans. It is one of the most dramatic transformations in natural history. A land mammal eventually becoming the largest animal ever known. And yet, the ocean still hides much of their lives from us. Even today, scientists cannot easily track blue whales continuously across the open sea. Satellites lose them. Storms obscure them. Deep dives hide them. Entire populations remain difficult to study because the whales spend most of their existence far from human eyes. There is something haunting about that. Human civilization mapped continents, walked on the moon, and placed machines on Mars. Yet the largest creature ever known still moves through Earth's oceans, partly unseen. Sometimes researchers encounter them suddenly, in fog or darkness, and describe an almost emotional reaction. Not fear exactly, more like disorientation. The whale feels too large to process correctly, too calm, too ancient. The movement does not resemble ordinary wildlife. It feels geological, like watching part of the planet itself shift beneath the water. And perhaps that feeling reveals something deeper about blue whales. They force humans to confront scale. Not just physical scale, but planetary scale. Their migrations stretch across oceans. Their feeding depends on climate systems. Their survival depends on microscopic krill populations connected to sea ice and ocean currents. Even their existence reminds us how enormous Earth truly is beneath the thin layer humans control. But there is another reason blue whales feel almost unreal. They should have disappeared. During the industrial whaling era, humans hunted blue whales at catastrophic levels. Fast steam-powered ships and explosive harpoons suddenly allowed hunters to kill creatures that had once been too difficult to catch. In only a few decades, populations collapsed. Some estimates suggest blue whale numbers dropped by over 90% in certain regions. Entire oceans grew quieter. And because blue whales reproduce slowly, recovery remains uncertain even now. Some populations have shown encouraging rebounds since international protections began, but others remain fragile. Ship strikes, warming oceans, noise pollution, and changing krill ecosystems still threaten them in ways scientists continue trying to understand. Which means the largest animal in Earth's history may also be one of the most vulnerable. That contradiction lingers in the mind. A creature enormous enough to outweigh dozens of elephants, yet delicate enough that changes in temperature, sound, or food supply can reshape its future. And maybe that is why blue whales feel so mysterious. They are not monsters ruling the ocean. They are survivors balanced carefully inside a system larger than themselves. Cold currents, deep water, ice-covered feeding grounds, ancient migration paths older than human civilization. The blue whale did not conquer the planet through violence. It became gigantic by adapting perfectly to the rhythms of Earth itself. And somewhere tonight, beneath black waves and distant stars, one of those giants is still moving slowly through the dark, carrying the weight of an ancient world inside its heartbeat. Long before blue whales crossed entire oceans beneath polar storms and moonlit waves, their ancestors walked through mud on 4 legs. That sounds almost impossible at first. When people imagine evolution, they usually picture small changes happening gradually inside creatures that still resemble one another. A slightly different jaw, longer teeth, better eyesight. But whales are different. Whales feel like a complete rewriting of reality itself. The largest animals ever known did not begin as fish-like sea creatures. They began as mammals on land, breathing air beneath hot, prehistoric skies. And for a very long time, scientists struggled to understand how that transformation could even happen. Because if you go back far enough into Earth's history, there were no whales in the oceans at all. No dolphins, no orcas, no blue whales singing beneath the Pacific. The seas were filled with other life forms entirely. Giant marine reptiles had already risen and vanished millions of years earlier. Ancient oceans belonged to creatures like mosasaurs and plesiosaurs, long before mammals entered the water in any serious way. Then, after the extinction of the dinosaurs around 66 million years ago, the planet became strangely open again. Ecosystems shifted, empty niches appeared, and somewhere near shallow rivers and coastlines, certain mammals began drifting toward the sea. Not all at once, probably not even intentionally. At first, the change may have been subtle enough that nobody would notice it happening if they could travel back in time. An animal spending slightly more time near water, hunting fish in rivers, escaping predators by swimming, feeding along muddy coastlines where food was plentiful. But evolution has a strange habit of rewarding tiny advantages over immense stretches of time. And eventually, some mammals began changing in ways that pointed toward the ocean. One of the earliest known creatures connected to whale ancestry is called Pakicetus. The name sounds exotic and almost mythical now, but the animal itself would not have looked particularly extraordinary if you saw it alive. It resembled a lean predator somewhere between a wolf, a large fox, and a primitive deer-like mammal. It had 4 legs, fur, a long tail. It walked on land beneath humid forests in what is now Pakistan roughly 50 million years ago. At first glance, nobody would mistake it for a whale. And yet, hidden inside its skull were clues that changed paleontology forever. The bones around the ear region shared unusual structures found in modern whales. That discovery stunned researchers because it connected a fully land-based mammal to creatures living deep in the sea today. Suddenly, whale evolution no longer looked like a vague mystery. It became a trail, a strange one, because the more fossils scientists uncovered, the stranger the story became. After Pakicetus came creatures that seemed increasingly uncomfortable choosing between land and water. One of the most famous was Ambulocetus, often nicknamed the walking whale. It lived around 48 million years ago and looked almost unsettling. Imagine a crocodile mixed with a large mammal. Heavy body, powerful limbs, long snout filled with teeth. It likely moved awkwardly on land, but swam far more effectively in water. Some scientists think Ambulocetus hunted similarly to crocodiles today, lurking near riverbanks before lunging at prey. Others believe it may have spent more time scavenging or ambushing fish in shallow water. There is still debate about exactly how aquatic it truly was. But what matters is the direction evolution was heading, toward the sea. And once that movement began, the body started changing rapidly. Legs slowly shortened and strengthened for swimming instead of running. Spines became more flexible. Feet may have developed webbing. Tails grew increasingly important for propulsion. The nose began migrating upward along the skull in one of the strangest anatomical shifts in mammalian history. That migration eventually produced the blowhole. Modern whales breathe through nostrils located on top of the head, allowing them to surface briefly without lifting much of the body from the water. But early whale ancestors still had forward-facing noses like ordinary land mammals. Fossils reveal this movement happening gradually across millions of years, almost like evolution physically pulling the face backward over time. And perhaps the strangest part is that whales never stopped being mammals. Even after fully returning to the sea, they still breathed air. They still gave live birth. Mothers still produced milk. Deep beneath all the layers of adaptation, whales remained tied to their land ancestry in ways fish never were. That creates a fascinating contradiction. Whales look perfectly designed for ocean life today. So perfectly, in fact, that many people instinctively think of them as ancient sea creatures. But evolution did not create them directly for the ocean. it reshaped something else into ocean life piece by piece. Which raises an uncomfortable question. Why go back at all? Leaving the ocean for land was one of the most revolutionary events in the history of life. Early vertebrates spent millions of years adapting to gravity, air, and dry environments. So why would mammals return to the sea after all that evolutionary effort? Scientists still debate the deeper reasons. Food is probably part of the answer. Ancient coastlines and shallow seas offered enormous feeding opportunities. Fish populations were abundant. Competition on land may have been intense. Water also provides buoyancy, allowing larger body sizes without the crushing effects of gravity. But some researchers suspect climate shifts played a role too. Ancient Earth during the Eocene was warmer than today. Sea levels were different. Coastlines stretched across enormous regions. Entire ecosystems existed where land and shallow water blended together almost seamlessly. For animals living there, the transition may not have felt dramatic at all. Generation after generation simply drifted farther outward. And eventually, some descendants stopped needing land entirely. One of the most important discoveries in whale evolution came from creatures called Basilosaurus and Dorodon. Despite the name, Basilosaurus was not a dinosaur. Early paleontologists actually mistook it for a giant marine reptile because its skeleton looked so strange. It stretched nearly 60 feet long and moved through warm prehistoric oceans around 40 million years ago. Unlike earlier ancestors, Basilosaurus was fully aquatic. It could no longer walk properly on land, but hidden near the rear of its massive body were tiny hind limbs, small, useless remnants of the legs its ancestors once used to walk across ancient ground. Those little limbs may be one of the eeriest details in natural history, because they are like ghosts inside the skeleton. Evidence that blue whales, humpbacks, and dolphins all carry the memory of land animals within their bodies even now. Modern whales still possess tiny vestigial pelvic bones buried deep inside muscle, disconnected from walking entirely. Evolution rarely erases everything cleanly. Instead, it layers new worlds over old ones. And the ocean changed whale senses in extraordinary ways too. Sound became more important than sight underwater, because light fades rapidly beneath the surface. Ears adapted to detect vibrations traveling through dense water over incredible distances. Bodies became insulated with thick fat layers against cold temperatures. Forelimbs transformed into flippers, while fingers remained hidden inside, still structurally recognizable beneath the flesh. That detail feels almost surreal once you realize it. Inside a whale flipper is something disturbingly close to a modified hand. Not a fish fin, a hand rewritten by millions of years underwater. The deeper scientists looked, the more whale evolution began feeling less like fantasy and more like one of the clearest demonstrations of how dramatically life can transform when environments change slowly enough. And yet, there are still mysteries. Some researchers question whether current fossil discoveries fully capture how fast these transitions occurred. Others debate how certain whale ancestors behaved socially or hunted prey. Entire branches of early whale evolution remain incomplete because fossilization is rare and uneven. Most ancient coastlines disappeared long ago beneath modern seas, hiding evidence humans may never recover. There is also something emotionally strange about realizing that every blue whale carries an invisible connection to forests, rivers, and muddy prehistoric shorelines. Because when a modern whale surfaces to breathe, it is performing an ancient act inherited from land mammals. Fish extract oxygen from water. Whales still gasp air beneath the sky. That single fact quietly reveals their entire history. And perhaps that history explains why whales feel so intelligent and emotionally complex to humans. Mammals evolved around social bonds, parental care, learning behaviors, and communication. When mammals returned to the sea, they carried many of those neurological traits with them. Over millions of years, the ocean reshaped their bodies without fully erasing the emotional architecture beneath. Some scientists caution against projecting human emotions too strongly onto whales. That debate remains active. But there is little doubt whales possess sophisticated communication systems, long-term memory, and unusually large brains relative to body structure. And all of that began with small mammals wandering too close to ancient water. The transformation almost feels impossible when viewed all at once. A four-legged animal walking beneath tropical trees, eventually becoming a blue whale, crossing entire oceans beneath Arctic storms. Yet evolution rarely works through sudden miracles. It works through accumulation, tiny advantages repeating across unimaginable stretches of time until the final result looks disconnected from where it began. And maybe that is why whale evolution unsettles people so deeply. Because it reminds us that life on Earth is not fixed. The boundaries humans imagine between land and sea, mammal and ocean creature, familiar and alien, are far less permanent than they appear. Somewhere beneath the dark Pacific tonight, a blue whale is moving through black water with effortless grace. But hidden deep inside its skeleton are traces of footsteps from a world that disappeared tens of millions of years ago. In the deepest parts of the ocean, there are sounds moving through the darkness right now that no human ear will ever naturally hear. Not because they are too quiet, but because they are too deep. Far below the range of ordinary hearing, blue whales send slow vibrations through the water like living earthquakes. Some of these calls travel hundreds of miles. Under the right ocean conditions, scientists believe certain low-frequency whale sounds may travel even farther, slipping through cold layers of water across enormous sections of the planet. Which means a whale somewhere near Antarctica could, in theory, be heard far beyond the horizon by another whale humans will never see. That idea changes the feeling of the ocean almost immediately. The sea no longer feels silent. It feels crowded with invisible conversations. And for most of human history, nobody even realized those conversations existed. Sailors crossing the Atlantic centuries ago often described the ocean as eerily empty at night. Once the wind calmed and the ships stopped creaking, there were moments of almost total darkness and silence. But beneath their hulls, whales may have been communicating constantly through frequencies too low for humans to notice. An entirely different world of sound was operating below them. Because underwater, sound behaves differently than it does on land. In air, voices weaken quickly. Mountains block noise. Forests absorb it. But seawater is denser and more efficient at carrying vibration. Low-frequency sounds especially can travel extraordinary distances through certain ocean layers where temperature and pressure guide sound almost like tunnels. Some researchers compare parts of the ocean to giant acoustic highways, and blue whales evolved to use them. Their calls are among the lowest frequency vocalizations known in the animal kingdom. Some pulses fall below 20 Hz, entering ranges humans feel more than hear. If you were close enough underwater, the sound might not resemble singing at all. It could feel like pressure moving through your chest, a slow vibration spreading through dark water. That physical sensation may partly explain why whale encounters affect people so deeply. The sounds do not behave like ordinary animal noises. They feel environmental, almost geological. And yet these immense vibrations come from living mammals breathing air beneath the same sky humans do. Exactly how blue whales produce these sounds is still not fully understood. Scientists believe air moves through specialized structures deep inside the body, creating resonance without the whale needing to exhale continuously like humans speaking. Water pressure, body size, and internal anatomy all seem to contribute to the incredible depth of the calls. And body size matters enormously. Large animals naturally produce lower frequencies because bigger structures vibrate more slowly. A violin cannot produce the same notes as a massive church bell. Blue whales, with bodies longer than many houses, effectively became giant living instruments designed by evolution over millions of years. But these sounds are not random. Patterns appear again and again. Certain calls repeat seasonally. Some populations seem to have regional differences, almost resembling accents. Researchers tracking whale songs discovered something unexpected. Blue whale vocalizations have gradually changed over time in several ocean regions. In some cases, the average pitch has slowly lowered across decades. Nobody knows exactly why. Some scientists suspect changes in population density may influence how whales communicate. Others wonder whether warming oceans alter sound transmission enough to affect vocal behavior. There are even hypotheses suggesting whales may unconsciously adjust calls in response to rising ocean noise created by humans. And that noise has become impossible to ignore. Before industrialization, oceans were far quieter places. Wind, storms, earthquakes, and animal sounds dominated the underwater world. Then humans filled the seas with engines. Cargo ships, oil drilling, naval sonar, propellers constantly vibrating across migration routes that whales had followed long before human civilization existed. Modern oceans hum with mechanical noise. To humans standing on ships, that sound pollution often feels invisible because most of it happens underwater. But to whales relying on low-frequency communication across huge distances, the change may be enormous. Some marine biologists describe parts of the ocean today as acoustically crowded in ways that barely existed a few centuries ago. Imagine trying to hold a conversation across a dark city while construction machinery operates constantly in the background. That may be close to what whales experience now. And perhaps nowhere does the emotional side of whale sound become clearer than in the story of the so-called 52 Hz whale. For years, underwater monitoring systems detected calls at an unusual frequency, around 52 Hz, far higher than typical blue whale vocalizations. The whale behind the sound became famous because researchers never found another whale consistently answering it. Newspapers eventually called it the loneliest whale in the world. That description may be emotionally exaggerated. Scientists still debate what species the whale actually was and whether it truly lived in isolation. Some suspect it could have been a hybrid whale or an individual with unusual anatomy. Others argue whales may have responded in ways humans simply failed to detect. Still, the idea captured public imagination instantly. A single voice moving through dark oceans for years without response. There is something deeply human about that image, even if the scientific reality remains uncertain. And maybe that emotional connection reveals something important about whale communication itself. Because whale songs do not sound purely functional. They sound expressive. Long repeating moans, pulses, rhythmic sequences drifting through black water beneath storms and ice fields. Some recordings feel less like animal calls and more like signals from another intelligence hidden below the surface of the Earth. Scientists are cautious about over-romanticizing this. Whale communication is incredibly complex, but complexity alone does not automatically mean language in the human sense. Researchers continue debating how much information whales actually encode inside their calls. Some believe the sounds mainly help individuals locate one another across vast distances. Others suspect social coordination, mating behavior, navigation, or emotional signaling may also play important roles. There is even speculation that whales use the ocean itself, almost like a map. Low-frequency sound can reveal information about underwater geography, ice coverage, storms, and distant coastlines. A whale moving through darkness may perceive the ocean in ways humans barely understand, not visually, but acoustically. That possibility changes the atmosphere of the deep sea entirely. To humans, the deep ocean feels blind. To whales, it may feel full of shape and structure carried through vibration. And blue whales are not simply hearing these sounds. They are living inside them. Some researchers suspect whales may sense portions of the underwater soundscape through the body itself, not only through ears. Sound waves traveling through dense water interact physically with massive whale anatomy in ways still being studied. Their world may be built from pressure, resonance, and vibration far more than ours is, which makes silence underwater almost impossible. Even in remote oceans, the sea is alive with movement. Ice cracking thousands of miles away. Earthquakes beneath tectonic plates. Rain striking the surface. Distant propellers. Schools of fish shifting direction. Other whales singing somewhere beyond visible range. The ocean is closer to a giant living sound field than an empty void, and blue whales evolved perfectly for it. Their hearing appears especially adapted for low frequencies. Ironically, this means they may struggle more with higher frequency human-made sounds than people first assumed. Certain sonar systems, naval exercises, and industrial activity may interfere with whale behavior in ways scientists still cannot fully measure. Some strandings of marine mammals have raised difficult questions about acoustic disruption. Not every case is directly linked to human sound, and the evidence varies by species and circumstance. But concern about underwater noise pollution has grown steadily over the past few decades, because sound underwater is not a small detail. For whales, sound is survival. It is orientation, connection, possibly memory, possibly even culture. Researchers studying humpback whales discovered song patterns spreading across populations, almost like musical trends moving through ocean regions. Blue whales appear less elaborate musically, but there are hints that certain vocal traditions may persist across generations. If true, whale songs may carry social continuity stretching far longer than humans once imagined. And then there is the unsettling possibility that humans are still hearing only a fraction of what whales are actually communicating. Technology helps, but it remains limited. Hydrophones capture portions of the underwater world, yet oceans are immense and layered with interference. Some whale calls likely remain undetected. Others may contain subtleties current analysis methods fail to interpret. In a strange way, humans may stand in the same position today that early astronomers once occupied before decoding the structure of the cosmos. Listening to signals without fully understanding the system behind them. The difference is that these signals are not coming from distant galaxies. They are coming from living creatures sharing Earth with us right now. And somewhere tonight, beneath miles of black ocean water, a blue whale may already be singing into the darkness. A slow, low-frequency pulse rolling across cold underwater plains, older than human civilization itself. No audience, no spotlight. Just sound moving endlessly through the sea, like a memory the planet has been carrying for millions of years. A blue whale can grow larger than any dinosaur ever discovered, while surviving on animals smaller than your thumb. At first, that sounds like a mistake. When people imagine gigantic predators, they usually picture giant teeth, violent hunts, and massive prey struggling in dark water. It feels logical that the largest animal in Earth's history should feed like a monster from a prehistoric movie. But blue whales evolved toward something far stranger. They became giants not by hunting bigger creatures, but by mastering abundance itself. Because the ocean hides a secret that most humans never truly see. Tiny things rule it. Far beneath the surface, entire worlds exist, made almost entirely of microscopic life and drifting swarms so enormous they can sometimes be detected from space. In certain seasons, cold, nutrient-rich oceans explode with biological activity. Phytoplankton bloom near the surface. Small creatures feed on them. Then, larger creatures arrive to feed on those swarms. Layer after layer, the food chain rises upward until eventually it reaches the blue whale. And near the center of that system is one of the most important animals on Earth: krill. Most people imagine krill as small shrimp, which is close enough for a first impression. But seeing them in person changes the feeling immediately. They are delicate, translucent crustaceans, often only a few inches long, drifting through freezing water in staggering numbers. Individually, they seem insignificant, but together they form dense, moving clouds, stretching across parts of the ocean like living weather systems. Some swarms are so concentrated that predators can detect them from remarkable distances. And blue whales evolved to find them. That may be one of the strangest realities in nature. The largest animal ever known survives by targeting one of the smallest concentrations of life large enough to sustain it. In a way, blue whales are not hunting individual prey at all. They are hunting density. They are searching for places where the ocean itself becomes thick with food. And once they find it, the scale of feeding becomes almost unbelievable. A feeding blue whale does not nibble. It engulfs. The whale accelerates beneath a krill swarm, opens its mouth, and suddenly transforms into something that barely resembles a normal animal anymore. Long grooves running along the throat and underside begin expanding outward dramatically. The mouth fills with seawater and prey so rapidly that the whale's body seems to distort under the pressure. For a few seconds, it becomes a moving net, swallowing an entire section of ocean. The amount of water taken in during a single lunge can weigh as much as the whale itself. That sounds physically impossible at first. But blue whales evolved specialized anatomy to survive these extreme feeding events. Their throat pleats stretch like enormous elastic folds. Their tongue shifts backward. Water pressure floods through the mouth, while muscles and connective tissue absorb astonishing force. Then comes the filtering. Blue whales do not have teeth. Instead, they possess long curtain-like structures called baleen hanging from the upper jaw. These plates are made from keratin, the same material found in human fingernails and hair, but arranged into dense, bristled filters. As the whale forces water back out through the baleen, the krill remain trapped inside. Then the whale swallows, over and over again, sometimes hundreds of times in a single feeding day. And all of this depends on timing, because krill are not evenly spread across the ocean. They gather seasonally in cold, productive waters where sunlight, nutrients, currents, and sea ice interact in extremely specific ways. Places like Antarctica become biological engines during feeding seasons. The ocean there may look empty from above, but below the surface, enormous quantities of life are constantly moving. Blue whales follow those rhythms with incredible precision. Their migrations are deeply tied to food availability. During productive seasons, whales feed intensely, storing massive energy reserves in the form of blubber. That stored energy helps support long migrations across oceans where feeding becomes less reliable. In some ways, a blue whale spends much of its life balancing energy mathematics. Every movement matters. Every dive costs oxygen. Every feeding lunge requires enormous physical effort. And scientists eventually discovered something surprising about those lunges. They are expensive. Extremely expensive. Researchers attaching digital tags to whales found that lunge feeding may be one of the most energetically demanding behaviors in the animal kingdom. Accelerating a body that massive through dense water takes immense power. The whale must carefully target krill-rich zones dense enough to justify the effort. Which means gigantism only works when the food source is abundant enough to support it. That detail may explain why blue whales evolved relatively recently compared to some earlier marine giants. Certain scientists suspect that modern ocean conditions, especially the rise of nutrient-rich polar ecosystems, helped create an environment capable of supporting such enormous filter feeders. In other words, blue whales may exist because Earth accidentally assembled the perfect feeding system for giants. Cold oceans, massive krill blooms, seasonal productivity, global currents transporting nutrients across entire hemispheres, a planetary machine feeding creatures larger than buses. And yet, the whole system remains fragile. Because krill themselves depend heavily on microscopic life and sea ice ecosystems. In Antarctica especially, young krill feed around the underside of ice sheets where algae grow in cold, nutrient-rich water. Changes in temperature, ice formation, and ocean chemistry can ripple upward through the entire food chain, which raises a troubling possibility. If krill populations decline severely, blue whales may struggle no matter how protected they are from hunting. That connection feels strangely unsettling because it reveals how dependent giants can be on tiny, invisible organisms. The blue whale appears powerful enough to dominate the ocean, yet its existence may partly depend on microscopic algae growing beneath floating ice. Scale becomes almost meaningless out there. The giant survives because the tiny survives first. And perhaps nowhere does this become clearer than during feeding dives. A blue whale descending beneath the surface enters a world humans rarely witness directly. Sunlight fades rapidly, water pressure rises. Schools of fish scatter through blue darkness, while krill gather in shifting layers beneath the sea. The whale moves with surprising control for something so enormous, adjusting position carefully before lunging upward through dense prey clouds. Researchers studying these dives noticed another fascinating detail. Blue whales often time their feeding based on krill behavior itself. Krill migrate vertically through the water column, depending on time of day, light conditions, and predator activity. At certain hours, they remain deeper. Later, they rise closer to the surface. Whales appear highly adapted to tracking these patterns efficiently, almost like farmers following invisible harvest cycles beneath the ocean. And despite all this feeding, blue whales are remarkably selective in a way. They do not simply eat constantly. They target quality. high-density krill patches provide the greatest energy return. Sparse prey may not justify the physical cost of feeding. Some scientists even suspect whales make sophisticated, energetic decisions while hunting, unconsciously calculating whether a feeding opportunity is worth the effort. That possibility changes the emotional feeling of blue whales again. They stop seeming like passive, drifting giants. Instead, they become highly optimized animals navigating an incredibly precise energy economy. And still, even after decades of research, humans likely underestimate how difficult this lifestyle truly is. Imagine needing millions of tiny prey just to maintain your body. Imagine crossing entire oceans, searching for invisible concentrations of drifting life. Imagine relying on climate systems, sea ice, and microscopic algae without ever consciously understanding any of it. The blue whale survives inside one of the largest ecological chains on Earth, while perceiving only fragments of the system holding it alive. In that sense, it is not so different from humans. We also depend on invisible planetary systems most people rarely think about. Currents, oxygen cycles, microorganisms, climate stability, food webs stretching across continents and oceans. Blue whales simply make those connections easier to see because their size magnifies every dependency dramatically. And perhaps that is why the story of their feeding feels almost philosophical at times. The biggest creature in Earth's history survives not through dominance, but through balance. Not through violence, but through timing. Not through endless strength, but through an ancient relationship with some of the smallest life forms in the sea. There is something strangely humbling about that, especially when you realize how much remains hidden below the surface even now. Scientists still debate how changing oceans will affect future krill populations. Some regions show concerning declines linked to warming temperatures and shifting ice patterns. Other areas remain difficult to study consistently because Antarctic ecosystems are enormous, remote, and constantly changing. The future of blue whales may depend on processes humans can barely monitor in real time. Tiny drifting crustaceans, invisible algae beneath sea ice, currents moving silently across polar oceans. A chain so delicate that breaking one part could echo upward toward the largest animal ever known. And somewhere tonight, beneath freezing southern waters, a blue whale is already feeding in darkness, opening its mouth through vast underwater clouds of krill, while millions of tiny bodies scatter through black water like living dust in the beam of an unseen light. Somewhere tonight, in the middle of the Pacific, a blue whale may be sleeping just beneath the surface of the water. Not in a cave, not on the ocean floor, not hidden safely away from the world, just floating slowly in the dark, surrounded by thousands of feet of cold, open ocean. And the strangest part is this: even while sleeping, it still has to remember to breathe. That single fact changes everything about what sleep means for a whale. For humans, breathing is automatic. You fall asleep, your body continues working in the background, and your lungs keep moving without conscious effort. But whales are mammals that returned to the sea millions of years ago without ever fully escaping one ancient problem. They still breathe air. No gills. No way to extract oxygen directly from water. Every breath must happen intentionally, which creates a terrifying possibility that land mammals never face. If a whale entered the same kind of deep unconscious sleep humans experience, it could simply stop surfacing. And in the ocean, that mistake would be fatal. So evolution found another solution, a strange one. A solution so unusual that for years scientists struggled to fully understand it. Because whales do not sleep the way most animals do. Part of their brain remains awake. This phenomenon is often called unihemispheric sleep, and at first it almost sounds fictional. One half of the brain enters a sleep-like resting state, while the other half stays active enough to maintain awareness, control breathing, and monitor the environment. Then, the sides switch. In other words, blue whales may spend much of their lives never becoming fully unconscious at all. Imagine what that means for the feeling of existence itself. A creature crossing dark oceans for decades, never completely asleep the way humans are, never fully letting go, always partially alert beneath the water. Researchers first began uncovering this strange adaptation while studying dolphins and smaller whales, but evidence strongly suggests large whales rely on similar neurological strategies. Complete deep sleep underwater would simply be too dangerous for air-breathing giants living in open ocean. And breathing is only one problem. The ocean at night is not peaceful in the way humans often imagine. It is dark, yes, quiet from above, but below the surface, life continues constantly. Currents move, temperatures shift, predators roam. Storm systems alter water pressure and wave motion across enormous distances. Even large whales remain vulnerable in certain situations, especially calves, which means sleep for a whale is less like shutting down and more like drifting carefully through partial rest while remaining connected to the world around it. Some observations suggest whales sometimes enter slow-motion resting states near the surface, barely moving at all. Early sailors occasionally described whales floating motionless in calm water, almost like giant drifting logs. At the time, many people assumed the animals were sick, injured, or dying. But in some cases, they may simply have been resting. The image feels eerie once you understand what is happening. A creature larger than a bus, floating silently beneath moonlight, while half its brain sleeps and the other half keeps watch over the sea. And perhaps even stranger is the question scientists still cannot answer completely. Do whales dream? Nobody knows for certain. Dreaming in humans is strongly associated with deep REM sleep, a neurological state involving complex brain activity and near-total muscle relaxation. But marine mammals appear to experience sleep differently, and clear evidence of REM sleep in large whales remains limited and difficult to study. That uncertainty creates a fascinating possibility. Whales may experience consciousness in ways humans have never directly understood. Not fully awake, not fully asleep, something in between, a drifting state shaped by millions of years underwater. And the ocean itself may have helped create that state. On land, sleep often involves safety. Animals retreat into nests, dens, trees, caves. They reduce awareness temporarily because they possess environments stable enough to allow it. But open ocean offers very little true shelter. A whale cannot simply stop moving completely for long periods in every situation. Water temperatures, buoyancy, breathing, currents, and social coordination continue mattering even during rest, especially for mothers. Blue whale calves enter one of the harshest childhoods on Earth almost immediately after birth. The newborn must swim, surface, nurse, and migrate through enormous oceans while still developing strength and coordination. During early life, the calf depends almost entirely on staying close to its mother. And astonishingly, scientists suspect whale mothers may sleep very little during these periods. Research involving dolphins and other cetaceans has suggested mothers and calves can remain in nearly continuous motion for weeks after birth. Some scientists believe certain marine mammals suppress deep sleep almost entirely during the earliest stages of calf development, though many details remain uncertain for blue whales specifically, because observing them continuously in open ocean is extraordinarily difficult. Still, the implications are staggering. A mother guiding her newborn through dark water while barely resting at all. Always surfacing, always listening, always moving. That level of constant awareness changes how sleep itself feels in the marine world. Rest becomes flexible, fragmented, adapted around survival rather than comfort. And perhaps humans underestimate how exhausting that lifestyle truly is. Blue whales travel thousands of miles across changing oceans while maintaining immense bodies requiring enormous oxygen and energy management. Even resting carries risks. Drifting too deeply could interfere with breathing patterns. Remaining near shipping routes could expose whales to collisions. Noise pollution may disrupt communication or orientation in ways researchers still struggle to measure fully. The modern ocean is not the same ocean whales evolved in. For millions of years, whale sleep existed inside a world dominated mostly by natural sounds: currents, storms, ice, distant animal calls. Now parts of the sea vibrate constantly with engines and propellers. Some scientists wonder whether chronic human noise subtly alters whale stress levels or resting behavior over long periods. The truth is, we still know surprisingly little. That may be one of the most humbling parts of whale research. Even with satellites, drones, underwater microphones, and digital tracking systems, large portions of whale life remain hidden simply because the ocean itself hides them so well. A sleeping blue whale is not easy to study. It can disappear beneath the surface for long periods, drift through remote waters, or rest in darkness far beyond direct observation. Much of what scientists understand comes from fragments, tagged individuals, laboratory studies on smaller cetaceans, behavioral patterns observed over time, which means there may still be aspects of whale sleep humans have never witnessed directly. And the more researchers study marine mammals, the stranger the boundary between sleep and awareness begins to look. In humans, unconsciousness is familiar. We disappear into sleep each night and return hours later with little memory of the transition. But whales may experience rest as something more fluid, a gradual shifting of attention rather than total absence, a neurological compromise shaped by the impossible demands of living underwater while still breathing air. In a way, whales never fully escaped their land ancestry. Every breath reminds them of it. Every resting cycle depends on it. Millions of years after returning to the sea, they remain tethered to the atmosphere above the waves. And that dependency creates moments of incredible vulnerability. A sleeping whale calf separated from its mother could quickly become disoriented. A resting whale near heavy ship traffic may not react fast enough to avoid danger. Even natural threats still exist. Orcas occasionally target young whales. Sudden environmental shifts can disrupt migration routes or feeding behavior. The ocean never completely stops demanding awareness, which may explain why whale sleep feels so different from our own. Humans often think of sleep as escape, leaving the world behind temporarily. But whales seem to carry the world with them even during rest. The ocean remains present inside the sleeping process itself. Sound, pressure, movement, breathing, the endless rhythm of surfacing and descending beneath the stars. And perhaps there is something strangely beautiful about that. Because blue whales spend their entire existence suspended between two worlds. Mammals tied to air, yet living inside water. Giants powerful enough to cross oceans, yet vulnerable enough that even sleep had to evolve into something cautious and incomplete. That tension exists in every resting whale tonight. Half awake, half dreaming perhaps, drifting slowly through black water older than human civilization. And somewhere far beneath the surface, a blue whale may already be entering that strange, quiet state now. Its massive body barely moving in the dark, while one side of its mind slips into rest, and the other continues listening to the ocean around it. Every year, somewhere in the cold southern oceans, a blue whale begins moving north. Not randomly, not wandering, but following a route older than human civilization itself. The journey stretches across thousands of miles of open ocean where there are no roads, no visible landmarks, no mountains rising above the horizon to point the way. Just water in every direction. Endless moving water beneath changing skies. And yet somehow, these whales continue finding the same distant regions generation after generation with astonishing consistency. That may be one of the strangest navigation mysteries on Earth, because blue whales do not simply migrate. They cross entire hemispheres. Some populations travel between polar feeding grounds and warmer breeding waters across distances so vast they almost stop feeling real. A whale may spend months moving through the Pacific, slipping beneath storms, shipping lanes, underwater mountain ranges, and darkness deeper than most humans will ever experience. And for much of that journey, nobody sees it. The ocean hides migration in a way land never can. Birds crossing continents fill the sky in visible formations. Herds moving across African plains leave dust behind them. But whales vanish beneath the surface, carrying out some of the longest known migrations on the planet, almost entirely unseen. For centuries, humans barely understood where they went. Early whalers noticed patterns. Certain regions suddenly filled with whales during specific seasons, then emptied again. But the full scale of whale migration remained mysterious for a very long time. Because tracking an animal across entire oceans was nearly impossible before modern technology. And even now, the journeys still feel almost unreal once mapped fully. A blue whale feeding in cold Antarctic waters may later travel toward tropical or subtropical regions thousands of miles away. Along the western coast of North America, some blue whales move between nutrient-rich feeding zones off California and breeding areas farther south, near Mexico and Central America. Other populations follow routes across the Indian Ocean or through parts of the southern hemisphere that remain difficult to monitor continuously. The distances involved are staggering, and what makes them even stranger is how precisely the whales seem to navigate. Because the open ocean does not look organized from a whale's perspective the way maps make it appear to humans. There are no painted borders underwater, no visible migration highways, no signs pointing south. Yet whales repeatedly locate productive feeding grounds and return to important regions with remarkable accuracy. How? That question still has no complete answer. Scientists suspect whales rely on multiple overlapping systems at once. Sound may play a major role. Low-frequency ocean acoustics can travel immense distances, potentially giving whales information about coastlines, storms, ice conditions, and underwater geography. Ocean currents themselves may also provide environmental cues through temperature and salinity changes. Some researchers believe whales may even sense Earth's magnetic field. That possibility sounds almost supernatural at first, but many migratory animals appear capable of detecting subtle magnetic patterns. Sea turtles, birds, and certain fish species show evidence of magnetoreception. If whales possess similar abilities, they may experience the planet in ways humans cannot directly perceive at all. Imagine feeling invisible lines stretching across oceans beneath you. A hidden planetary map built into the Earth itself. And perhaps even more mysterious is the idea that migration routes may be culturally transmitted rather than purely instinctive. Young whales often travel beside their mothers during early life. Over time, calves may learn routes, feeding grounds, timing patterns, and behavioral strategies from older generations. If true, whale migration becomes something more than biology alone. It becomes inherited memory moving across oceans through living experience. That changes the emotional feeling of migration completely. A blue whale crossing the Pacific may not simply be following instinct. It may be following tradition. Ancient paths repeated across generations so many times that the routes themselves became part of whale society. And some of those routes may be astonishingly old. Modern blue whales evolved relatively recently in geological terms, But whale migration behavior likely stretches back through countless climate cycles, ice ages, and shifting oceans. Long before humans built cities or crossed seas in ships, whales were already navigating planetary-scale journeys beneath the water. That thought becomes difficult to fully absorb. Entire human civilizations rose and disappeared while whales continued migrating silently through the same oceans. And migration is not optional. It is survival. Cold waters near the poles often provide extraordinary feeding opportunities because nutrient-rich currents fuel enormous blooms of krill. Blue whales gorge themselves there during productive seasons, storing vast energy reserves inside thick blubber layers. But colder environments may not always be ideal for calving newborns. Warmer waters can offer safer conditions for young whales with less thermal stress. So the whales move, feeding in one world, giving birth in another, living between extremes. And every mile of that movement costs energy. Blue whales do not travel quickly compared to some smaller marine animals. Their migrations unfold gradually over weeks and months, powered by immense tails pushing through dense water with slow, rhythmic motion. A migrating whale may cover huge distances while appearing almost calm. But beneath that calmness lies constant physical effort. Currents resist movement. Storms alter conditions. Food availability shifts unpredictably. And modern oceans have introduced entirely new dangers. One of the most serious is ship traffic. Large commercial vessels now cross many whale migration routes continuously. Container ships, oil tankers, cruise liners, enormous machines moving through oceans day and night. To humans aboard them, the sea may appear empty, but underwater, whales may be feeding, resting, surfacing, or traveling directly beneath shipping corridors. Collisions have become a growing concern in several regions. And perhaps the most unsettling part is how easily they can happen. A blue whale surfacing near a fast-moving cargo ship may have very little time to react. Visibility conditions, underwater noise, and the whale's own behavior all affect the outcome. In some cases, the ship crew may not even realize a collision occurred. The scale difference feels horrifying in a strange way. One of the largest animals ever known, vulnerable to machines humans built only recently. And ships are not the only challenge. Fishing gear, warming oceans, changing krill distribution, and underwater noise pollution may all interfere with migration patterns in ways scientists are still trying to understand. Some feeding grounds appear to be shifting as ocean temperatures change. If krill populations move, whales may eventually need to alter migration timing or routes developed across countless generations. That possibility raises difficult questions. Can cultural migration patterns adapt quickly enough to environmental change? Do whales experiment with new routes over time? How flexible are these ancient systems? Researchers are still searching for answers. And despite all our technology, tracking whales across entire migrations remains surprisingly difficult. Satellite tags eventually detach. Weather disrupts observation. Deep dives hide movement. entire sections of whale journeys still vanish into uncertainty. In some ways, migration remains one of the last great hidden movements on Earth, especially at night, because the ocean becomes something entirely different after dark. Surface visibility disappears. Moonlight reflects across endless waves, while whales continue traveling beneath the water almost invisibly. Sometimes they rise to breathe beside stars and vanish again before dawn. Sometimes entire migrations may pass offshore unnoticed by the millions of people sleeping along nearby coastlines. There is something haunting about that. These giant animals are constantly moving through the edges of the human world without most people realizing it. And perhaps migration changes the whales themselves emotionally too. Long journeys shape behavior. They expose whales to changing soundscapes, temperatures, feeding opportunities, and social encounters. Certain regions may become associated with abundance, others with danger. Calves likely experience migration as the structure around which early life forms, learning when to surface, where to travel, how to survive the scale of the ocean itself. A young whale born in warm water may eventually cross into polar seas, colder and larger than anything it has ever known. And still, it keeps moving, following older whales through darkness toward feeding grounds hidden beyond the horizon. That image feels almost mythic, not because it is fantasy, but because it is real. A living migration stretching across half the planet, beneath storms and stars. And maybe that is why whale migrations continue fascinating scientists so deeply. They reveal how little humans truly understand about navigation, memory, and animal perception. A blue whale does not carry maps. It does not calculate coordinates consciously the way humans do. Yet it crosses oceans with consistency sophisticated enough to rival some human navigation systems, all while moving through an environment humans are poorly designed to experience ourselves. And somewhere tonight, beneath black water and distant moonlight, a blue whale may already be continuing that ancient journey now, swimming steadily through invisible migration corridors that existed long before the first human ever looked out across the sea. There was a time when parts of the ocean became quieter than they had been in millions of years. Not because storms stopped, not because the sea changed, but because the largest animals on Earth were disappearing from it. One by one, entire migration routes that had once carried blue whales across hemispheres began emptying into silence. In some regions, sailors who once saw blows rising regularly from the horizon started crossing oceans without seeing a single whale at all. And at the center of that disappearance was something deeply strange about human history. People did not hunt blue whales because they hated them. They hunted them because the modern world was hungry. Hungry for oil, for fuel, for industry, for light. Long before electricity reached most cities, whale oil helped illuminate streets, homes, factories, and lamps across growing industrial societies. Whales became moving reservoirs of valuable material floating through the oceans. Their blubber could be processed into oil. Their baleen was used in products ranging from corsets to umbrella ribs before plastics existed. Even parts of their bones entered manufacturing systems. By the 19th century, whales were no longer simply animals in the human imagination. They had become resources. And blue whales survived partly because they were too difficult to kill. That sounds almost unbelievable now, considering their size. But earlier whaling technology struggled against creatures that large. Traditional sailing ships and hand-thrown harpoons worked best against slower species easier to approach. Blue whales were fast, powerful, and often lived far offshore. Many whalers considered them nearly impossible to hunt consistently with older methods. Then industrialization changed the ocean forever. Steam-powered ships arrived first. Unlike sailing vessels, steamships no longer depended on wind direction. They could pursue whales directly across open water with far greater speed and control. Then came one of the most devastating inventions in marine history: the explosive harpoon. Developed in the 19th century and later refined further, these harpoons transformed whaling into industrial-scale killing. Instead of relying on manually thrown weapons, hunters now launched explosive projectiles from mounted cannons. A whale struck successfully might suffer catastrophic internal injuries almost instantly. Suddenly, blue whales were no longer protected by their size. Their size became the reason they were targeted, because every successful kill represented enormous quantities of oil and material, and the scale escalated quickly. Factory ships eventually appeared, massive floating processing stations capable of hauling, cutting, boiling, and storing whale products directly at sea. Whaling fleets no longer needed to return immediately to shore after each hunt. Entire industrial operations could remain in remote oceans for extended periods, processing whales continuously while moving through feeding grounds. The ocean started functioning like an extraction zone, and perhaps the most disturbing part is how efficient the system became. Spotter planes searched from above. Steam-powered catcher boats pursued whales relentlessly. Harpoons exploded into bodies larger than buses, while crews raced to process carcasses before decomposition or sinking made recovery difficult. In some cases, compressed air was pumped into dead whales simply to keep them afloat long enough for harvesting. There was almost nothing ancient or traditional about this anymore. This was industrial machinery applied to living giants, and blue whales were catastrophically unprepared for it, because evolution had never needed to prepare them for humans. For millions of years, adult blue whales had few natural predators capable of threatening them consistently. Orcas sometimes attacked calves or weakened individuals, but fully grown blue whales existed near the top of the marine food chain simply because of their immense size. Their greatest dangers came from environmental shifts, starvation, illness, or accidents, not organized hunting by intelligent, tool-using predators. Then humans arrived, with engines and explosives, and within only a few decades, populations collapsed. The exact historical numbers remain debated, because early whaling records were often incomplete or intentionally manipulated. Some fleets underreported catches to avoid regulations later on. But researchers broadly agree that blue whale populations in many regions were devastated at astonishing speed during the 20th century. Some estimates suggest Antarctic blue whale numbers fell by over 90%. That statistic barely feels real at first. A creature that survived ice ages, climate shifts, and millions of years of ocean change, nearly erased in the span of a human lifetime. And many people at the time still believed the oceans were effectively endless. That belief shaped much of industrial history. The sea looked infinite from the deck of a ship. Whale populations once seemed impossibly large. Few early industries truly understood how slowly giant whales reproduced, or how vulnerable large migratory populations could become under sustained mechanized hunting. Blue whales mature slowly. They produce relatively few calves. Recovery takes time, far more time than industrial extraction systems were willing to allow. And perhaps that is why the silence became so frightening. In some whaling regions, sightings dropped so dramatically that people began realizing something extraordinary was happening. Oceans that once held giant moving populations suddenly felt empty. Scientists, conservationists, and even some former whalers started warning that continued hunting might push certain species toward extinction. At first, not everyone believed it. The idea that humans could eliminate creatures so enormous seemed almost absurd. Blue whales felt too big to disappear, too widespread, too ancient. But size does not protect animals from systems designed for mass extraction. In fact, size often makes them more valuable targets. And there was another unsettling detail about whaling that changed how humans emotionally understood whales forever. People got close to them, very close. Whaling crews spent hours beside dead whales during processing. They saw the eyes, the scars, mothers near calves, massive bodies slowly losing heat in freezing ocean air. Some sailors described moments of discomfort or emotional conflict, especially as public attitudes toward whales slowly began changing during the 20th century. Because whales no longer looked like monsters. They looked intelligent, social, aware, and perhaps nowhere did this shift become more powerful than through sound recordings and underwater research. As scientists revealed the complexity of whale communication and migration behavior, the old industrial image of whales as simple floating resources began collapsing. The giants of the ocean started feeling personal. That emotional transformation changed politics too. International concern over whale populations eventually led to increasing regulation. The International Whaling Commission, established in the mid-20th century, gradually introduced protections as evidence of severe population declines grew stronger. Blue whales eventually received legal protection from commercial hunting, though illegal whaling and enforcement issues complicated the picture in some regions for years afterward. Even today, the legacy remains complicated. Some communities historically depended economically and culturally on whaling traditions stretching back generations. Industrial commercial whaling, indigenous subsistence hunting, and modern conservation movements do not all fit neatly into one moral category. Historians often caution against flattening the issue into simple narratives because motivations vary dramatically across cultures and time periods. Still, few scientists doubt the scale of destruction inflicted on blue whale populations during industrial whaling. The numbers were catastrophic. And perhaps the strangest part is that many whales alive today may still carry echoes of that era in ways humans barely understand. Researchers studying whale behavior have wondered whether severe population collapse altered migration knowledge, communication networks, or social structures passed between generations. If whale culture exists in meaningful forms, and many scientists suspect aspects of it do, then industrial whaling may have erased more than bodies alone. It may have erased memory, ancient roots, learned behaviors, acoustic traditions, entire social continuities stretching across oceans. That possibility feels haunting because so much disappeared before humans truly understood what whales were. And despite protections, the danger never completely ended. Modern blue whales still face threats from ship strikes, climate change, entanglement, pollution, and changing food systems. The difference is that today, humans are watching more carefully, listening more carefully, trying, perhaps imperfectly, to protect creatures once hunted almost without limit. Some populations have shown signs of recovery. Others remain fragile. And there are still oceans where blue whales are encountered far less often than historical records suggest they once were. The silence never fully left. Maybe it never will. Because extinction does not always happen all at once. Sometimes it begins as absence spreading quietly through familiar places. Fewer sightings, longer gaps between songs, migration routes growing emptier over generations, until eventually, nobody alive remembers how crowded the ocean once sounded. And somewhere tonight, beneath dark water and distant stars, a blue whale is still moving through seas where its ancestors were hunted by steamships and explosive harpoons not very long ago at all. A survivor from one of the largest industrial hunts in human history, still crossing oceans, still singing into the dark, while the world above slowly tries to decide what responsibility means after nearly silencing the largest animal Earth ever created. At some point, far out in the open ocean, every blue whale takes its final breath. There is no graveyard, no shoreline ceremony, no visible monument left behind on the surface. For a short time, the body may float. Air trapped inside enormous lungs and tissues can keep the whale suspended beneath waves while currents slowly carry it through the sea. Seabirds circle overhead. Fish gather below. The ocean begins reacting almost immediately. And then, eventually, the giant starts to sink. What happens next may be one of the strangest hidden events on Earth. Because when a blue whale dies, an entire ecosystem can be born from its body. Scientists call this a whale fall. The name sounds simple, almost gentle, but the reality is immense. A blue whale carcass descending into the deep ocean is less like a dead animal and more like a sudden delivery of an entire forest's worth of nutrients into one of the most food-starved environments on the planet. The deep sea is not empty, but it is often hungry. Far below the reach of sunlight, food arrives slowly. Tiny particles drift downward from the surface like underwater snow. Dead organisms sink occasionally into darkness. Life survives there, but energy is limited. Every scrap matters. Then suddenly, from above, something the size of a bus begins falling through the black water. Thousands of pounds of flesh, fat, bone, protein, an entire mountain of biological material descending into the abyss. And for creatures living in the deep ocean, that event can change everything. At first, the whale falls silently. The deeper it sinks, the colder and darker the water becomes. Pressure rises enormously. Sunlight disappears completely. The body drifts through layers of ocean few humans will ever directly witness. Strange fish may approach from the darkness. Sharks sometimes feed before the whale reaches the bottom, tearing away chunks during descent. In some cases, scavengers begin arriving long before the carcass settles fully on the sea floor. Then finally, after hours or even longer depending on depth and conditions, the whale lands, and the deep sea wakes up around it. One of the first arrivals is often hagfish. These primitive eel-like scavengers slide into openings in the carcass and begin feeding rapidly. Sleeper sharks, amphipods, and other opportunistic creatures gather from the surrounding darkness. Some scientists, comparing early whale fall stages, have described them almost like sudden explosions of activity in otherwise sparse ecosystems. For a while, the site becomes crowded, not with giant monsters as movies often imagine, but with persistence. Thousands upon thousands of small organisms converging on concentrated food that may not appear again nearby for years. And the scale matters enormously. A single blue whale contains enough organic material to support deep-sea communities for decades under certain conditions. That fact barely feels real at first. Decades. One body continuing to feed life long after death. The first phase is often called the mobile scavenger stage. Large scavengers strip away soft tissue, sometimes surprisingly fast. Depending on ocean depth, temperature, and scavenger populations, much of the flesh may disappear within months or a few years. But the whale fall is only beginning, because the bones remain. And inside those bones is something extraordinary. Whale skeletons contain enormous quantities of lipids and nutrients trapped deep within the structure itself. In the deep ocean, specialized bacteria begin breaking down these compounds chemically, releasing substances that entirely new communities of organisms can use. This creates the next phase of the whale fall, one far stranger than simple scavenging. Chemosynthetic ecosystems begin forming around the bones. To humans, most life feels connected to sunlight. Plants grow through photosynthesis. Animals eat plants or other animals. The chain begins with the sun. But deep beneath the ocean, some ecosystems operate differently. Certain bacteria generate energy from chemical reactions rather than sunlight, supporting life in total darkness. Whale falls can help fuel these systems. As bacteria break down whale bones, they release chemicals like hydrogen sulfide that specialized organisms can exploit. Entire biological communities emerge around this process, including creatures that seem almost alien compared to ordinary ocean life. and some of them exist nowhere else. One of the strangest examples is the bone-eating worm Osedax. At first glance, these worms barely resemble animals most people recognize. They attach themselves directly to whale bones deep underwater and survive through symbiotic bacteria that help extract nutrients from inside the skeleton. They have no conventional mouths for chewing bone apart. Instead, they penetrate the surface and slowly consume the hidden organic material within. The discovery shocked scientists because suddenly, whale skeletons were not just leftovers. They were habitats, and perhaps even evolutionary stepping stones. Some researchers have proposed that whale falls may have helped deep-sea species spread across vast ocean regions over evolutionary time. A whale carcass landing on the seafloor creates a temporary oasis of nutrients in an otherwise difficult environment. Organisms adapted to whale falls might migrate from one carcass site to another over generations, forming hidden biological networks across the deep ocean. If true, dead whales may have shaped deep-sea evolution itself. That possibility changes the emotional feeling of death underwater entirely. The whale does not simply vanish. It transforms into landscape. And perhaps the strangest part is how little humans knew about this until relatively recently. For most of history, whale falls remained invisible because humans rarely reached the deep seafloor. The ocean hid the process almost perfectly. Only with modern submarines, remotely operated vehicles, and deep-sea exploration did scientists begin observing these ecosystems directly. The discoveries felt almost surreal. Researchers descending into darkness expected emptiness, and instead found entire communities surrounding ancient whale skeletons, crabs crawling across ribs, pale worms protruding from bones, fish hovering in black water around what looked like the remains of some enormous, forgotten beast. The deep sea had been recycling giants all along, without human awareness. And there are still mysteries. Scientists continue debating how common whale falls truly are throughout the oceans. In modern times, whale populations are far smaller than before industrial whaling, which may have reduced the number of whale fall ecosystems reaching the seafloor. Some researchers wonder whether certain deep-sea species declined indirectly because fewer carcasses reached the abyss after large whale populations collapsed. That idea is difficult to fully process. Industrial whaling may not only have removed whales from the oceans, it may have altered ecosystems miles beneath the surface that humans never even knew existed at the time. The connections run deeper than they first appear. Even carbon cycling may be affected. Whale bodies store enormous amounts of carbon gathered over long lifetimes. When carcasses sink into the deep sea, portions of that carbon may remain trapped far below the surface for extended periods rather than re-entering the atmosphere quickly. In a strange way, whales continue influencing planetary systems even after death. And sometimes, the ocean does not let them sink immediately. Dead whales occasionally wash ashore instead, creating scenes both tragic and unsettling. Coastal communities throughout history encountered enormous carcasses decomposing on beaches, releasing gases and attracting scavengers. In rare cases, trapped gases inside decomposing whales built enough internal pressure to cause violent ruptures. These bizarre events became infamous reminders of just how massive whale bodies truly are. But most blue whales disappear downward, into darkness, into pressure, into silence. And perhaps that silence is what makes whale falls feel almost sacred to some scientists. Not in a mystical sense exactly, but in the sense that the deep ocean transforms death into continuity with astonishing efficiency. Nothing is wasted for long. Flesh feeds scavengers. Bones feed bacteria. Bacteria support entire ecosystems. Even after decades, fragments of the skeleton may still hold traces of energy from a life that crossed oceans beneath the stars. The giant continues feeding the sea long after movement stops. And maybe that changes how we think about endings themselves. On land, death often feels final and visible. Bodies decay beneath open sky. But in the ocean, especially the deep ocean, death becomes hidden transformation. Entire worlds emerge from what disappears. A whale that once migrated across hemispheres may eventually become home to creatures living in total darkness thousands of feet below the surface. Its final journey, creating life it never encountered while alive. And somewhere tonight, deep beneath black water colder than ice, there may already be a whale fall resting on the seafloor now, ribs stretching outward through darkness, while pale scavengers move slowly across the bones of one of the largest animals Earth has ever known. For all the satellites orbiting above Earth, for all the research ships, underwater microphones, drones, mapping systems, and decades of marine science, there are still moments when blue whales simply disappear. Not metaphorically, literally. A tagged whale may stop transmitting unexpectedly. A population tracked for years may suddenly become difficult to locate. Calls vanish from familiar regions. Feeding grounds shift. Entire stretches of ocean return almost instantly to uncertainty. And perhaps that is the strangest truth about blue whales. The largest animal ever known still lives partly beyond human understanding. That feels almost impossible in the modern world. Humans mapped the moon. We photograph distant galaxies. We monitor storms from space in real time. Yet much of a blue whale's life still unfolds beneath miles of moving water, where visibility collapses into darkness only a short distance below the surface. The ocean hides things extremely well, especially creatures built to survive inside it. And the deeper scientists study blue whales, the more unsettling certain questions become. Not because whales are supernatural, but because the ocean itself remains one of the least understood environments on Earth. Take communication, for example. Researchers have spent decades recording whale sounds across the world's oceans. They identified patterns, regional differences, migration-linked vocalizations, and low-frequency calls capable of traveling extraordinary distances underwater. Yet nobody can fully explain how much information whales are actually exchanging through these sounds. Are the calls simple location signals? Social bonding? Navigation tools? Mating displays? Warnings? Something more complex? The answer remains frustratingly incomplete. And sometimes, whales behave in ways that make the mystery even deeper. Certain vocal patterns spread gradually across populations, almost like cultural trends. Some whale groups appear to alter songs over time in coordinated ways difficult to explain through instinct alone. Younger whales may learn behaviors from older individuals rather than inheriting everything genetically. If that is true, and many researchers believe at least parts of it are, then whale societies may contain forms of culture moving silently across oceans for generations. Not human culture, but something that rhymes with it. Shared behaviors, learned migration paths, acoustic traditions, possibly even social memory. That possibility changes how blue whales feel emotionally to many scientists. The animals stop seeming like isolated drifting giants and begin resembling participants in hidden social worlds humans can barely observe directly. And perhaps nowhere does this uncertainty become more emotional than around whale intelligence itself. Blue whales possess enormous brains, but brain size alone proves very little. Sperm whales and some dolphins show particularly striking neurological complexity, though interpreting animal intelligence is always difficult because humans naturally compare everything against ourselves. Still, whales consistently display behaviors that raise difficult questions. Long-term memory, coordinated movement, complex communication, strong mother-calf bonds, possible social learning. In some whale species, individuals have even been observed remaining near injured or dead companions for extended periods. What exactly do they understand about one another? Nobody knows. And scientists are careful here for good reason. It is easy to romanticize whales into human-like personalities the evidence cannot fully support. But it is equally possible humans underestimate forms of intelligence that evolved under completely different environmental pressures than our own. Because whales did not evolve in a world of fire, tools, and visible landscapes. They evolved in darkness, in sound, in pressure and distance. A blue whale may perceive the ocean in ways humans are neurologically incapable of experiencing ourselves. That possibility becomes even stranger when researchers consider navigation. How does a whale cross thousands of miles of open ocean with such consistency? No complete answer exists. Earth's magnetic field may help. Acoustic landmarks may matter. Ocean currents, temperature gradients, memory, and inherited behavior likely interact together in ways scientists still struggle to separate clearly. And there are moments that make the mystery feel almost eerie. Whales sometimes arrive at feeding grounds with timing so precise it feels impossible from a human perspective. Generations appear to repeat routes stretching across hemispheres, even though oceans constantly shift around them. Some scientists suspect whales may carry mental maps far more sophisticated than humans once imagined. Others argue the explanation may emerge naturally from simpler, layered instincts interacting with environmental cues. The truth could involve both, or something else entirely. And then there are the places whales go where humans almost never follow. Large portions of the open ocean remain rarely visited even today. Certain regions are remote enough that observing whales continuously there becomes extremely difficult. Deep dives complicate matters further. A whale can vanish beneath the surface and move enormous distances before reappearing. The result is a strange gap in human knowledge. There are still parts of whale life that happen almost entirely outside direct observation. Birth behavior remains difficult to study in detail. Certain mating behaviors are poorly documented. Some population structures remain uncertain. Researchers continue debating how many distinct blue whale populations exist globally, because migration overlap and ocean movement complicate classification. And climate change may be altering patterns faster than scientists can fully track them. That uncertainty becomes especially unsettling when considering disappearing whale calls. In several regions, recorded blue whale vocalizations have gradually shifted downward in pitch over recent decades. Nobody completely agrees on why. Some researchers suggest recovering whale populations may no longer need to call as loudly if more individuals exist nearby. Others suspect changing ocean acoustics or stress factors may influence vocal behavior. The phenomenon remains unresolved. And that unresolved quality matters, because it reminds us how easy it is to mistake partial understanding for complete understanding. Humans know more about whales today than at any point in history. Yet the closer we look, the larger the unknowns often become. Even basic population numbers remain uncertain in some regions. Tracking animals across planetary-scale oceans is extraordinarily difficult. Weather interferes. Equipment fails. Deep water hides movement. Entire generations of whales may live and die with minimal direct human contact. There is something strangely humbling about that, especially in an age where humans often assume everything important has already been discovered. But the ocean still resists us. It absorbs visibility, distorts sound, conceals movement, and blue whales evolved perfectly for that hidden world. Some mysteries become even more philosophical. Do whales possess self-awareness in any meaningful sense? Certain dolphin species and other cetaceans have shown evidence consistent with mirror self-recognition tests, though interpreting those results remains debated. Blue whales themselves are far harder to study experimentally because of their size and lifestyle. But researchers increasingly suspect many marine mammals possess rich internal cognitive worlds humans barely understand. What does loneliness mean to a whale? Does grief exist in forms recognizable across species? What does memory feel like during a migration lasting thousands of miles? Nobody can answer these questions confidently, and perhaps that uncertainty itself is important. Humans often want nature to become fully explainable because explanation creates comfort. But whales remain partly mysterious precisely because they evolved in conditions radically different from those shaping human minds. Their world is pressure instead of gravity, sound instead of sight, distance instead of borders. And that different world may produce forms of perception difficult for humans even to imagine properly. There is also the haunting possibility that humans arrived too late to understand some parts of whale behavior completely. Industrial whaling devastated populations before modern marine science truly existed. Entire social structures, migration knowledge, or communication traditions may have been disrupted or erased before researchers began listening carefully. If whale culture exists in meaningful ways, some of it may already be gone. That idea lingers heavily in marine biology, because extinction is not always physical disappearance alone. Sometimes information disappears first. Learned behaviors vanish. Ancient migration continuity breaks apart. Social complexity collapses quietly inside shrinking populations, and the ocean keeps most of those losses hidden. Still, despite all the unknowns, blue whales continue moving through the sea tonight, exactly as they have for countless generations before humans ever understood they existed. Breathing, feeding, migrating, singing through black water beneath storms and moonlight. And somewhere far below the surface, there may already be sounds traveling through the ocean right now, carrying information humans do not yet know how to interpret. Signals crossing darkness between the largest animals Earth has ever produced. Messages hidden inside frequencies deeper than ordinary hearing. Reminders that even now, in the modern age, parts of this planet remain profoundly unexplained. Tonight, somewhere beneath the dark surface of the Pacific, a blue whale is still moving through the water exactly as its ancestors once did, long before human civilization existed. Slowly, calmly, following ancient migration routes through an ocean that no longer sounds the same as it once did. Because the modern sea is changing faster than many creatures inside it evolved to handle. And perhaps that is the quiet fear surrounding blue whales now. Not the fear of dramatic extinction arriving overnight, but something slower and more difficult to measure. A gradual reshaping of the world around them. Water temperatures shifting year after year, ice patterns changing, feeding grounds moving. Human noise spreading deeper into the oceans. A future arriving invisibly beneath the surface. For millions of years, blue whales survived ice ages, volcanic eras, and enormous climate shifts. They adapted to changing oceans long before humans appeared. That history sometimes creates a comforting assumption that whales will simply adapt again no matter what happens next. But the present situation may be different in one important way. The pace. Natural climate transitions in Earth's past often unfolded across extremely long stretches of time. Entire ecosystems shifted slowly enough for migration patterns, food systems, and evolutionary pressures to adjust gradually. Modern warming is happening far more rapidly than many ancient environmental transitions visible in the geological record. And blue whales are deeply connected to systems that react sensitively to temperature, especially krill. The relationship between blue whales and krill may be one of the most important ecological dependencies in the ocean. Giant whales survive because tiny crustaceans gather in enormous quantities. But krill themselves depend on cold water ecosystems influenced by sea ice, ocean circulation, algae growth, and nutrient flow. In places like Antarctica, sections of the food web begin beneath floating ice. That detail feels almost surreal once fully understood. The largest animal ever known may ultimately depend on microscopic life growing beneath frozen sheets of drifting ice at the bottom of the world, which means warming oceans can ripple upward through the entire system. Scientists are still debating exactly how severe future impacts may become, because Antarctic ecosystems are incredibly complex. Some krill populations appear vulnerable to changing ice conditions. Other regions may temporarily remain productive or shift geographically rather than collapse entirely. Ocean systems are dynamic, and predicting long-term outcomes remains difficult. But uncertainty itself becomes dangerous when an animal depends on precise feeding opportunities spread across enormous distances. Blue whales cannot simply survive anywhere. They need oceans functioning in very specific ways. And those oceans are becoming louder too. Before industrialization, whale songs traveled through seas dominated mostly by natural sound. Wind, storms, earthquakes, cracking ice, distant marine life. Now, many migration routes vibrate continuously with engines and propellers. Cargo ships cross the oceans day and night, carrying global trade through waters whales have used for millions of years. To humans standing on shore, the ocean may still appear peaceful, but underwater, certain regions have become acoustically crowded, and sound matters profoundly to whales. It shapes communication, navigation, awareness, possibly social bonds. Researchers continue studying how chronic underwater noise affects whale behavior over long periods. Some evidence suggests whales may alter vocal patterns around shipping traffic. Other studies raise concerns about stress, disrupted feeding behavior, or interference with long-distance communication. The full consequences remain uncertain. And perhaps that uncertainty appears again and again whenever scientists discuss the future of blue whales. There are warning signs, but there are also signs of resilience. After commercial whaling protections expanded during the 20th century, some blue whale populations began recovering slowly. In certain regions, sightings increased over time. Acoustic monitoring detected whales returning to areas where they had once nearly vanished. Conservation efforts, shipping regulations, and marine protected zones may already be helping in ways difficult to fully measure from year to year. That recovery matters because blue whales reproduce slowly. A female may carry a calf for nearly a year. Young whales require long periods of maternal care and development. Population rebounds unfold across decades rather than seasons, which means even successful recovery can appear frustratingly gradual from a human perspective. Still, the fact that blue whales survived industrial whaling at all feels remarkable. There was a moment when humans nearly erased them from parts of the planet forever. And yet, the giants remained. That persistence changes the emotional feeling of blue whales in an important way. They are not fragile in the ordinary sense. They survived ancient oceans humans can barely imagine. They crossed hemispheres long before maps existed. Their lineage endured planetary transformations spanning millions of years. But modern threats often arrive simultaneously. Climate pressure, ship strikes, fishing entanglement, noise pollution, chemical contamination, plastic spreading through marine food webs. Each problem alone may not destroy blue whales immediately. Together, however, they create an ocean increasingly shaped around human systems rather than ancient biological rhythms. And there is another possibility scientists discuss quietly sometimes. The ocean itself may become lonelier, because whale populations influence more than simple numbers. Whale songs fill migration corridors. Whale falls nourish deep-sea ecosystems. Whale movement redistributes nutrients through marine environments in ways researchers are still uncovering. Some scientists even describe whales as ecosystem engineers, helping shape ocean productivity over enormous scales. When whale populations decline, the silence spreads outward through other systems too. That idea feels haunting because humans rarely notice silence developing gradually. A generation grows up hearing fewer whale songs than the previous one and assumes the quieter ocean is normal. This shifting baseline effect appears throughout environmental history. People unconsciously accept reduced abundance because they never witnessed what existed before. Entire migrations shrink. Species disappear from familiar coastlines. Oceans grow emptier 1 decade at a time until memory itself fades. Blue whales remind us how easily that process can happen, because they are so large that their absence should feel impossible to ignore. And yet for decades, many populations declined almost invisibly beneath the surface. Still, despite everything, there are moments of hope hidden inside the science, too. New technology allows researchers to track whales with greater precision than ever before. Drones capture behavior impossible to observe clearly from ships alone. Acoustic networks monitor underwater soundscapes across vast regions. Satellite data helps identify productive feeding grounds and dangerous shipping overlaps. Humans are finally beginning to listen to the oceans more carefully. Perhaps not perfectly, but differently than before. Some shipping lanes have been modified in regions where whale collisions became especially severe. Speed restrictions in certain areas appear to reduce fatal strikes. International cooperation around marine conservation has grown in ways that would have seemed unlikely during the height of industrial whaling. The future is still uncertain, but uncertainty cuts both ways. It means collapse is possible. It also means recovery remains possible. And perhaps blue whales symbolize something larger than conservation alone now. They reveal whether humans can coexist with systems bigger and older than civilization itself. Whether industrial societies can recognize limits before silence spreads too far through the living world. Because blue whales are not simply large animals. They are evidence that Earth once created conditions stable enough for giants to exist peacefully across entire oceans. Cold currents, endless migrations, dark feeding grounds beneath polar ice, low songs moving through black water across hundreds of miles. A planetary rhythm older than human history. And tonight, somewhere beneath the stars, that rhythm still continues. A blue whale rises slowly toward the surface. the sea around it remains almost completely dark. Then, suddenly, a column of mist erupts into cold night air as the whale exhales after another deep dive. For a few seconds, the giant becomes visible again. Then it slips quietly beneath the water and disappears back into the moving darkness of the ocean, carrying the memory of an older Earth into a future humans are still deciding how to shape. Tonight, we're exploring the mysterious world of blue whales, the largest animals to ever live on Earth. From ancient ancestors to hidden ocean songs and deep sea survival, this is a relaxing journey into the secrets of these gentle giants. Before we begin, leave a comment below telling me what city you're watching from tonight. And if you enjoy documentaries like this, don't forget to subscribe and let me know what topic I should explore next. Sleep well tonight.